Hello students, welcome to delayed classes. In this chapter, we are going to study what is atom, what are the fundamental particles, what is electromagnetic radiation, what are the atomic theories, what is spectrum, what is quantum mechanical model, what is electronic configuration. What is an atom? Atom is a smallest particle which involves in a chemical reaction. This atom word is obtained from Greek language. In Greek, atomio means uncut. We can't cut further. Indian and Greek philosophers also said that atoms are the fundamental building blocks of the matter. For example, for a wall, brick is the smallest unit. Similarly, for a matter, atom is the smallest unit. On further observation, these atoms are made up of subatomic particles. The main subatomic particles are electrons, protons, and neutrons. Here we are going to see the characteristics of cathode rays. The cathode rays are originated at cathode, and they see here, this is the first point. Here it is originated. They travels in a straight line in the absence of electrical and magnetic fields. The cathode rays are deflected in electrical and magnetic fields. See here, this ray is deflected towards positive. Here we have to remember cathode rays are generated at cathode. They traverse in a straight line in the absence of electrical and magnetic field, and they are going to deflect in electrical and magnetic fields. Some more. Cathode rays penetrates through a thin sheet. The thin sheet is there. Cathode rays can penetrate through the thin sheet. Cathode rays does not depend upon electrode, metal or a gas. In a discharge tube, if you are going to take any gas, it does not depend upon the gas. It does not depend upon the electrode or metal. So we have to say they are the basic constituents of all atoms. It is present in each and every atom and matter. Here, electrons are nothing but cathode rays. For that, J.J. Thomson calculated E by M, that is charge to mass ratio. Already in previous slide we have seen, that is it is going to deflect in electrical and magnetic field. Based on that deflection, they calculated E by M. See the first point, greater the deflection, greater the magnitude of the electrical and magnetic fields. The magnetic fields is more powerful, the deflection also more for an electron. Greater deflection by a lighter particle. If mass is less, deflection is more. The next one is, if deflection is more, when we apply more voltage. So based on these accurate measurements, J.J. Thomson calculated E by M, that for an electron, that is 1.76 into 10 power 11 coulombs per kg. You have to remember this one. Now here we are going to see the protons. In a discharge tube experiment, this is cathode, already we have seen, but it is made into fine holes. So this is known as modified cathode ray discharge tube. It led to the discovery of positive rays. Anode rays are generated by the gas. Here, when you are going to take the gas, these gas particles are bombarded by cathode rays. It gives plus and minus. These positive rays move towards the holes of cathode or canals. That's why they are called canal rays. Canal rays afterwards it is named as a protons. These are named as protons by Rutherford. Neutrons discovered by James Chadwick. How he discovered? By taking a beryllium thin sheet. When the thin sheet of beryllium is bombarded with alpha particles, see here alpha particles are there. He plus 2 is nothing but alpha particle. When it is bombarded, then it produced neutrons. The neutrons, it took a lot of time to determine. Why? Because there is no charge. They are chargeless. When you compare the mass of neutrons, neutrons mass is greater than mass of protons. Now the slide is very important. Now here particle, electron and proton. Charge, electron minus 1.6 into 10 power minus 19 coulombs. Proton same but sign is different. Mass in kgs, electron 9.1 into 10 power minus 31 kgs, whereas for proton 1.672 into 10 power minus 27 kgs. Mass in AMU 0.00055 AMU. For proton 1.007 AMU. Now per mole 0.55 milligrams, for electron 1.007 grams for proton. Specific charge 1.76 into 10 power 11 coulombs per kg, whereas for proton 9.6 into 10 power 7 coulombs per kg. You have to remember this slide perfectly. Neutrons, charge 0, mass 1.674 into 10 power minus 27 kgs, 1.008 AMUs, 1.008 grams, and specific charges. Now here we came to atomic models. The first model has been given by J.J. Thomson. That is plum pudding model, raisin pudding or watermelon. See here the watermelon is there. This red fibrous part is nothing but positive charge. The positive charge is uniformly distributed in an atom. Now in an atom, the red fibrous part is uniformly distributed. These are the seeds. The seeds are embedded in a red fibrous part. So from J.J. Thomson, we have to remember 2 points. That is, atom is spherical, atom is neutral. That's all. He was failed to explain why these electrons are not neutralized, how these electrons are shielded from neutralization. This concept is not clearly explained by J.J. Thomson. That's why this is not a good concept for atomic model. Now we are going to see Rutherford's atomic structure. Rutherford proposed atomic model based on alpha scattering experiment. For his experiment, he has taken golden foil. A beautiful question is there. Why he has chosen only the golden foil? Can you say that? We can make the gold into a thin sheet, very thin sheet. The other metals cannot be like that. So he has taken the golden foil. Its thickness is 100 nanometers. Already I said that alpha particles are nothing but He plus 2. When this golden foil bombarded with alpha particles, what happened? We'll see one by one. In Rutherford's experiment, golden foil is there. Most of alpha particles are passed through the golden foil. So these arrow marks are nothing but alpha particles are going through the golden foil. What is conclusion? Atom is mostly empty. Second observation. Few alpha particles are deflected by a small angle. See, these particles are deflected. These particles are deflected by a small angle. Why these are deflected? We know like charges repel each other. Something is there. Positive charge is there. Alpha particle also positive charge. Some positive charge is there in golden foil. Because of that, there is a small deflection. Observation 3. Very few particles. See, this is the one particle bounced back. Only 1 out of 20,000 are bounced back by 180 degrees. What is Rutherford's conclusion? Concluded like that, positive charge is concentrated in a very small volume. See here, it is a very small volume. This is like a football. This is like a football court. It is very minute. From all above observations, the positive charge and whole mass is present in the nucleus. This is the nucleus. In this, nucleons are there. What are the nucleons? Protons and neutrons. Electrons are revolving around the nucleus. So electrons are nucleus are held together by electrostatic force of attraction. Rutherford's atomic model. We have to learn some more points. Isotopes, same atomic number, different mass numbers. Protium 1H1, deuterium 1H2, tritium 1H3. Atomic number same, element is same, but mass number is different. Isotones, same number of neutrons. Isodiophers, same isotopic number. What is isotopic number? The difference between mass number and 2 times of atomic number. What is isostars? Atomicity. What does that mean? Number of atoms. And electrons are same. Then we have to say isostars. Example. N2 is there. In N2, atomic number 7. How many nitrogens are there? 2 nitrogens are there. Total 14 electrons. Whereas in carbon monoxide, carbon atomic number 6, oxygen atomic number 8, total 14 electrons. Here also 14 electrons, here also 14 electrons. At the same time, how many number of atoms are there? 2. Here how many number of atoms are there? 2. So atomicity is 2, electrons also 14, same. That's why they are known as isostars. Isoelectronic species. Which is isoelectron species? Same number of electrons. Now here sodium atomic number 11 plus it lost 1 electron. Now here 10 electrons. Mg plus 2. Here that is atomic number is 12. It lost 2 electrons. 10 electrons is remaining. Aluminium, atomic number is 13. It lost 3 electrons, remaining 10. Silicon, 14. It lost 4 electrons, remaining electrons are 10. In all these 4, same number of electrons. That's why they are isoelectronic species. The nature of light, characteristics we are going to study. What is wavelength? The distance between two successive crusts or troughs. It is going like a wave. It's going like a wave. So we know it is a transverse wave. For a transverse wave, that is two crusts or two troughs, the distance is known as wavelength. How it is measured? What are the units? Angstrom. 1 angstrom is equal to 10 power minus 10 meters. 1 nanometer, 10 power minus 9 meters. 1 picometer, 10 power minus 12 meters. 1 micrometer, 10 power minus 6 meters. We have to remember. What is the wave number? The number of waves present in 1 unit distance. How many waves are there in a 1 unit distance? That is known as wave number. Here the units are centimeter inverse and meter inverse. Just inverse of wavelength is nothing but wave number. Then what is frequency? The number of cycles per second or the number of waves passed through a fixed point is known as frequency. We know that is second inverse or hertz. The relation between the matter and radiation, the matter and energy. For that, see, for example, if iron is there. In a furnace, we are going to keep iron. First, it turns to dull red and goes on increasing the temperature. It becomes more red when the temperature increases. So, what does it mean? So, the frequency increases when you increase the temperature. How could you say that, sir? See here, you are supplying heat. So this is the iron rod. So if you are going to supply more heat, the radiation also more. So it gives more energy. Now the energy is directly proportional to frequency. This concept has been given by Max Planck. See here, E is proportional to nu, pronunciation NEU. E is equal to h nu. E is equal to hc by lambda. From C, velocity is equal to distance per second. Now here, that is E is equal to hc nu bar, where C is equal to nu lambda. C is equal to 3 into 10 power 8 meters per second, velocity of light. Planck's constant h is equal to 6.625 into 10 power minus 34 joules second. Then we have to remember nu bar is equal to 1 by lambda. These formulae we have to remember. This is another example to know the relation between matter and energy. Now it is a metal plate or metal surface. When the light rays falls on the metal surface, what happens? Now see here, when the light ray falls on the metal surface, electrons are ejected. It is possible in all the cases? No, not at all. When the suitable frequency of light falls on the metal, then only electrons are ejected. That is the definition for photoelectric effect. See here, the ejection of electrons from metal surface by falling a suitable frequency of light. When the suitable frequency of light falls on the metal surface, then only electrons are ejected. The ejection of electrons are known as photoelectrons. These electrons are known as photoelectrons. For that, what minimum energy is required for ejection of electron is known as work energy or work function. Now here we have to look at the photoelectric effect. Now in this slide you are able to understand photoelectric effect bit clearly. Now this is the metal surface. So when the light falls on the metal, electrons are ejected. Now the question is, when the light falls on the metals, electrons are not ejected. When electrons are ejected, look at this one. The frequency is more than the frequency of work done, or critical frequency. When this frequency is greater than the frequency of the work done, then only electrons are ejected. The photoelectric effect is observed when the frequency of light is greater than critical frequency. If it is equal, what happens? Electrons are ejected, but it won't move from the metal surface. That's why kinetic energy is 0 if the frequency of the light is equal to frequency of the critical. In photoelectric effect, we have to remember 5 points. Number 1, the photons energy is equal to work done energy plus kinetic energy. The second one is the kinetic energy is equal to h into nu minus nu naught. Kinetic energy is directly proportional to photons energy independent of incident ray. See here, this is the photons energy. Now this is the kinetic energy. Kinetic energy. If photons energy increases, kinetic energy also increases. Number of electrons is directly proportional to intensity. Number of electrons is directly proportional to intensity. If the number of rays are more number of electrons are ejected. The number of rays per unit area is intensity. If the intensity is more, it liberates more number of stopping potential. Electron volts is equal to half mv square. We are saying that it is going with kinetic energy. What kinetic energy it possesses? How could you know that? By applying some voltage here. When you are going to apply some electron volts, the kinetic energy is going to be stopped. So that is known as stopping potential. The stopping potential in electron volts is equal to half mv square. These are the points we should remember. Once again tell me, the photons energy is equal to work done energy plus kinetic energy. The kinetic energy is equal to h into nu minus nu naught. Kinetic energy is directly proportional to photons energy. Number of electrons is directly proportional to intensity. The stopping potential electron volts is equal to kinetic energy, that is equal to half mv square. We should. In hydrogen spectrum, many lines are there. Don't worry, nothing is there. These lines represents around the nucleus. Shells are there. So that is first shell, n is equal to 1, Lyman series. Second shell, third shell, fourth shell, fifth shell, sixth shell, based on to honor the scientist. We have given the names of the scientist. Lyman series, Balmer series, Paschen series, Brackett series, Fund series and Humphrey series. Now, electrons will go to higher energy level. Again, they will come to ground level or middle, any other levels. Depends upon their energy. Now here the question they will ask you. If electron is there in n is equal to 6th level, if electrons are there in n is equal to 6th level, how many spectral lines are possible? For that very simple formula, the n2 of n2 minus 1 by 2 or n of n minus 1 by 2, where n or n2 is the higher value. They will give you from 6th level. Now n2 is 6. Then how many lines are there? 15 spectral lines are possible. Now are you going to count how many lines are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 11, 12, 13, 14, 15. Before we have seen very simple how many spectral lines are there? Tell me what is the higher value? Substitute n into n minus 1 by 2. You will get the answer. But they will ask you in Lyman series first line, Lyman series second line, Lyman series third line or red line, from red third line, they will ask you like that. Then how to calculate the energy? Now look at this one. The question, if it is the first line in Balmer series, N2 is Balmer series. That is also known as visible region. In visible region, the first line is red. For a red, they will ask you what is the energy difference? How much energy is lost or absorbed? How to calculate? For a first line, we have to see the limits n1 and n2. What is the formula? The nu bar is equal to 1 by lambda is equal to r into 1 by n1 square minus 1 by n2 square. For lower value, n1. For higher value, n2. If you are going to substitute, it gives nu bar. This nu bar we have to substitute here to calculate energy. But it's bit lengthy. Which is easy if you are perfect in the values. Now see N1, that is in Lyman series. What is the energy? 13.6 electron volts minus 3.4 electron volts minus 1.5 electron volts minus 0.8 electron volts minus 0.5 electron volts. If the question is what is the energy is absorbed or liberated while coming electron from N2 to N1. What is the energy difference? Very simple. We have to see the difference between these two. That is minus 1.5 electron volts minus of 3.4 electron volts. The energy difference is 1.9 electron volts. Your answer. It is over. No need to do calculations. That's why better to remember these values. You are perfect in hydrogen. One more thing you have to remember here. In hydrogen spectrum, instead of asking Balmer series, visible region or Paschen series or Fund series, they will ask you first excited state, second excited state. The electron comes from second excited state to ground state, or first excited state to ground state. Then for example, this is the ground state, this is first excited state, second, third. We have to add plus 1. Now here the electron moves from ground state to first excited state. They will ask you how much energy is absorbed. Already I said that you have learned all these things, that is 13.6 electron volts and 3.4 electron volts in negatives. When you see the difference of these two, that is nothing but 10.2 electron volts. How much energy is absorbed? That is 10.2 electron volts. So instead of that, the series they will ask you ground state, excited, first, second and third, like that. One more thing, already we calculated nu bar, but they will ask you what is lambda wavelength. Then it becomes inverse. R becomes 1 by R. Then remember that 912 angstroms are 91.2 nanometers. This RH, why it is mentioned RH? That is only for hydrogen. If it is other than hydrogen, we have to multiply with Z square, where Z is equal to atomic. Previous what you have seen, the relation between energy and the matter. These are has given an idea for Bohr's model of an atom. Bohr said that the first point is orbit. The path of electron, see here, this is the nucleus. This is nothing but a path of electron. This is a path of an electron. That is orbit. Second point is stationary orbit. This orbit is stationary. Why? Because its energy is constant. Whose energy? Electron's energy is constant. No loss of energy, no gain of energy. That's why that orbit is stationary orbit. Here many orbits are there. They are designated as 1, 2, 3, 4 KLMN respectively. The first orbit K, second orbit L, third orbit M, fourth orbit N. They are designated as 1, 2, 3, 4 KLMN. The next one is energy difference. When the electrons comes from lower energy to higher energy or higher energy to lower energy, they will gain energy or they will lose energy. From lower to higher, they will gain energy. From higher to lower, they will lose energy. The energy difference delta E is equal to E2 minus E1. That is equal to h nu. The electron is revolving with certain momentum, that is angular momentum. Angular momentum mvr is equal to nh by 2 pi. Atomic theory gives radius of nth orbit, energy of the nth orbit. Now we'll see radius of nth orbit. Now nucleus is there. Nucleus, protons are there. These protons are pulling the electrons towards the nucleus. That is the Coulombic force. That Coulombic force is minus Ze square by R square. Now when the force is pulling towards the nucleus, the opposite force also acting from the nucleus, that is centripetal force. The centripetal force is minus mv square by r. Electron is in a particular orbit. Centrifugal force is equal to centripetal force. That's why minus Ze square by r square is equal to minus mv square by r. From this, v square is equal to Ze square by mr. We know mvr is equal to nh by 2 pi, angular momentum. From this, v square is equal to n square h square by 4 pi square m square r square. Equation number 2. From first and second, we are going to get radius of the nth orbit is equal to n square h square by 4 pi square k z e square m. That is equal to 0.529 angstroms n square by z. Energy of the nth orbit. When the electron is there in a particular orbit, so it has potential energy and kinetic energy. The sum of potential energy and kinetic energy is nothing but total energy. The first of all, the potential energy is equal to minus kZe square by r. Kinetic energy is equal to kZe square by 2r. The total energy is equal to kinetic energy plus potential energy, that is equal to minus kZe square by 2r, where r is equal to n square h square by 4 pi square ze square m. By substituting all the values except z and n, we are going to get total energy minus 13.6 electron volts into z square by n square. You have to remember this value. Energy of the nth orbit already we have seen, minus 13.6 electron volts z square by n square, that is equal to minus 313.6 kilocalories z square by n square is equal to minus 1312 kilojoules z square by n square. You have to remember these three. Why? Because sometimes they will ask you in electron volts, sometimes in kilocalories or kilojoules. The energy of the nth orbit, if it is a negative, they will ask you what is ionization energy. The sign is positive, that is nothing but ionization energy. What is ionization energy? The energy is required to remove an electron from outermost shell of an atom. The limitations of Bohr's model. The first one is one electron species. He explained only one electron species. Bohrji, please explain helium. No, I can't explain. Remove one electron. I will explain only one electron species. Like that Bohr said. The second one is Zeeman effect and Stark effect. Bohr sir, why the atom is going to give many spectral lines in electrical field and magnetic field? If it gives many spectral lines in magnetic field, that is Zeeman effect. If it is gives in a electrical field, that is Stark effect. Bohr sir, please explain why it is. Bohr sir said that no answer. I don't know. Sir, you have given the relation angular momentum MVR is equal to NH by 2 pi. Please, how you derived? How it is satisfies the condition? I don't know. Just it is satisfying the condition, that's all. Sir, Bohr sir, tell me why atoms are involving in a bond? I don't know. So these are the drawbacks. So what about the last one? The last drawback we can see in Heisenberg's in dual nature. Now tell me what are the drawbacks? Number one, so it explained only one electron species. He couldn't explain Zeeman effect and Stark effect. Number three, he couldn't explain angular momentum. Fourth one, he couldn't explain why atoms are involved in a bond. The last one also is a drawback, but we will see in Heisenberg's. The quantum mechanical model of the atom. Quantum mechanical model of the atom. Here that is based on dual behavior of matter. That is de Broglie's wave equation, Heisenberg uncertainty principle, Schrodinger's wave equation. De Broglie says that matter has two natures. One is particle nature, second one is wave nature. If the particle is very small, the wave nature is more. For example, fly is there, house fly. So we can say it is going like a wave. So when the particle is very small, the wave nature is more. When the particle is very big, elephant is there, it is walking. But the wave nature is very minute. The body is vibrating, that is very minute. So he says that every particle has two natures. One is particle nature, second one is wave nature. The particle nature E is equal to mc square from Einstein. Wave nature E is equal to hc by lambda from Max Planck. Now from 1 and 2 we are going to get lambda is equal to h by mv. That is equal to h by momentum. De Broglie has given one more relation, that is n lambda is equal to 2 pi r. The number of waves is equal to the circumference of the particular orbit. Heisenberg uncertainty principle. Here Heisenberg says that it is impossible to determine its position and momentum simultaneously. Heisenberg has been given relation delta x and delta p is equal to h by 4 pi, where delta x is equal to uncertainty in its position, delta p is equal to uncertainty in its momentum is equal to, actually greater than or equal to, but in calculation we'll use always is equal. Just remember this one. In Heisenberg's, delta x and delta p is equal to what you have to remember? H by 4 pi. If delta x is equal to 0, if uncertainty in position is 0, then its momentum is equal to infinity. If the delta p is equal to 0, delta x is equal to infinity. This concept has been given by Heisenberg. What he says? It is highly impossible to determine its position and velocity simultaneously. Now, there is a controversy for Bohr's model with de Broglie's and Heisenberg's. Bohr said that what is an orbit? Orbit is nothing but a path of an electron. But de Broglie said that electron is going like a wave. Heisenberg says that it is impossible to determine its position and velocity simultaneously. Now there is a big problem where the electron is located in an atom around the nucleus. To solve these problems, based on de Broglie's and Heisenberg, Schrodinger has derived a beautiful equation, that is dou square psi by dou x square, dou square psi by dou y square, dou square psi by dou z square plus 8 pi square m by h square into e minus v into psi is equal to 0. This is for only one electron species, not for multi-electron atom. There, what is psi? The psi is nothing but a wave function. It is a continuous. It is finite. So it has positive values and negative values. It gives lobes. Psi is a wave function. It is a continuous. It is a finite. So when you go up, positive values comes down negative values and zeros also. It gives lobes. Now we have dumbbell shape, that is P is dumbbell, D is double dumbbell. So it gives lobes. Significance of psi square. It is a probability function. It is continuous. It has positive values only. Schrodinger's wave equation. They will ask you the number of radial nodes. Atom is spherical. Shells are there. So there is a along the radius where the electron is not there, that is node. Radial nodes along the radius. How many radial nodes are there for a particular orbital? How to calculate? The formula n minus L minus 1. Number of angular nodes, that is based on L values. The total number of nodes n minus L minus 1 plus L, we are going to get n minus 1. Please remember this formula. Number of radial nodes n minus L minus 1. Number of angular nodes L. Number of total nodes n minus 1 in orbitals. S orbital is spherical in shape. Along y-axis, x-axis, z-axis. Electron density is more. There is no nodal plane. That's why it is 0. In px, yz, easy to remember. 3 axes are there, x-axis, y-axis and z-axis. If x is there, remaining yz. Y is there, remaining xz. Z is there, remaining xz. Px, Py, Pz are same, but they differ in only orientation. They differ in only directions. Similarly, in dxy, please remember between x and y, just put one line, there keep z. Then xz and yz. Xz and yz are the nodal planes. Now tell me here, in between y and z, just draw one line, that is nothing but x, yx and xz. Yx and xz. Similarly, dxz, xy, yz. In dx square and y square, they are along the axis. Here, x plus y is equal to 0, x minus y is equal to 0. In dz square, no nodal planes. Why? Because along the z axis, y and x also is there, but on x and y, there is a small ring is there. Because of that, there is no nodal plane. In d orbitals, which is different, only dz square is different. Auber's principle. What is Auber's principle? Orbitals are filled by the electrons in the increasing order of their energies. That is based on Moeller diagram. What is Moeller diagram? That is 1s, 2s, 2p, 3s, 3p, 3d. Next one is 4s, 4p, 4d, 4f, like that. If you draw a line, 2p and 3s, then the rest of the lines are parallel to that. You are going to get the order 1s, 1s, then 2s, then 2p and 3s. 1s, 2s, 2p, 3s, 3p, 4s and 3d. In the increasing order of their energy levels, you have to fill the electrons. First, you have to fill 1s, next 2s, next 2p, next 3s, next 3p, next 4s, next 3d, and so on. Here, the opposite principle for hydrogen atom. The electrons are filled in order of n value or n energy level. 1s lesser than 2s is equal to 2p, lesser than 3s is equal to 3p is equal to 3d, lesser than 4s is equal to 4p is equal to 4d is equal to 4f. It depends upon only n values. For other than hydrogen, n plus L rule we have to follow. N plus L rule we have to follow. That is already we have seen. 1s, 2s, 2p, 3s, 3p, 4s, 3d and so on. Pauli's exclusion principle. Here the four quantum numbers are not same for two electrons in an atom. In orbital, two electrons are there. If it is 4s, n is equal to 4, L is equal to 0, M is equal to 0, S is equal to plus half. It can rotate in clockwise direction. Second electron, n is equal to 4, L is equal to 0, M is equal to 0, S is equal to minus half. It rotates in anti-clockwise direction. So three are same, but fourth one is not same. So Pauli's exclusion principle is four quantum numbers are not same for two electrons in an atom. It is going to differ in Hund's rule. In degenerate orbitals, which is a degenerate orbital where n plus L value is same. If it is a 3D, 3 plus D, L value is 2, 3 plus 2, 5. This is 5, this is n plus L 5, n plus L 5, n plus L 5, n plus L 5. So n plus L values are same. That's why they are called degenerate orbitals. For these degenerate orbitals, so the pairing takes place. When pairing takes place, all the available orbitals are filled with one electron each. Then only pairing takes place. That is Hund's rule.
Absolutely free. Chemistry assignments are available at www.delayedclasses.com. Hello students, I hope that it is more useful for you. You must subscribe. Why? Because you should not miss the next classes. See you. Bye.